our previous video, you already know what isotopes are. But if I tell you to go and get me a sample of chlorine atoms or get me 5 moles of carbon, you'll be very confused. Reason, because you don't know whether you should get carbon 12 or carbon 13. To avoid that confusion, scientists brought out a means to calculate the atomic mass of elements that exhibit isotopy. A means of getting a single mass that will represent a particular element that has isotopes. And that is what we call relative atomic mass of elements which have isotopes. That is the topic of discussion today. How do we calculate the relative atomic mass of isotopes? Elements that exhibit isotopes will get their atomic mass from the average mass of the various isotopes in relation to how they occur naturally in quantity. Already you know the meaning of average. But what do I mean by how they occur naturally in quantity? For instance, although I haven't seen any statistical data that will back up this statement, but if you look around you, you will believe that, as they said, that in the world, the number of girls or females is more than the number of males. The number of girls is more than the number of boys in the world. I don't know whether it's true, I haven't seen, but around me, I believe from that it is true. So also, elements that have isotopes, these isotopes, they don't exist in the same quantity. Some are more than the other in quantity. For instance, isotopes of chlorine. Chlorine 30, if you have 100 atoms of chlorine in a sample, then in a sample of chlorine, you will find out that in that sample, about 75 pieces or 75 atoms are chlorine 35, while about 25% is chlorine 37. So, that means they don't occur in the same quantity. So also is neon. Neon isotopes occur in different quantities. So in calculating their relative atomic mass, you calculate the average mass in relation to the abundance in nature. Let's see how it is done. These are solved examples that can explain what I mean. Number 1, calculate the relative atomic mass of chlorine. Given that the relative abundance of chlorine 35 is 75%, while that of chlorine 37 is 25%. Solution. The first thing you do is write the isotopes. This is chlorine 35, and this is chlorine 37. The abundance of chlorine 35 is 75%, while that of chlorine 37 is 25%. Then getting the average mass, which is the relative atomic mass, in relation to the abundance is 75% of chlorine 35 plus 25% of chlorine 37. That's all. What is 75%? That is 75 over 100 times chlorine times 35 plus 25% over 25 over 100, times 37. So 75% of 35 and chlorine 25% of chlorine 37. If you solve this, you get 26.25 plus 9.25. This will give you 35.5. So 35.5 is now the relative atomic mass of chlorine anywhere, anytime. No longer 35 or 37. You don't confuse it. So once you are asked of the relative atomic mass of chlorine, you quote 35.5. The second example says Calculate the relative atomic mass of element R, given the relative abundance of R63, 29 and R65, 29. The relative abundance are 68% and 62% respectively. Note that word. So we have R63 and R65. The abundance of R63 is 68% and that of 65 is 62%. So the relative atomic mass of R now is 68% of R63 plus 62% of R65, which is 68 over 100 times 63 over 1 plus 62 over 100, which is 62%, times 65 over 1. So you have 0.1 plus 0.01, plus 40.30, which will give you 40.31. So the relative atomic mass of R everywhere you go is 40.31. No longer 63 or 65. If you look at this, we don't concern ourselves with the atomic number, which is 17 or 29. No, there is nothing we use atomic number for here. Unlike the first video that taught how to get atomic mass of an element. So note this. Then I would like you to go solve this study question and see if you can get the answers given below. We have two study questions here. Solve that and see if you can get the answers given below. Then if you have any question, you ask me via email or message. Thank you.